Welcome back again to Advanced Functions, MHF4U 1. This is Trigonometric Identities and Equations chapter. In this lesson number 3, we are going to develop and use double angle formulas. So first, using the compound angle formula that we learned before, we're going to develop the formula for the double angle formula, specifically for sine. Recall, this is a new formula that you should keep in mind. This is a Pythagorean identity, and the Pythagorean identity is sine squared x plus cosine squared x is equal to 1, assuming that x is an angle. Okay, so this is a very important formula that you have to keep in mind, similar to a compound angle formula. Okay, now, so let's start by writing sine 2 theta. So sine 2 theta, I could divide it into a compound angle, a sine theta plus theta. And using the sine compound angle formula, I could write it as cosine theta times sine theta plus sine theta and cosine theta. Okay, so therefore, I have, because the theta, the angles are the same, it's 2 of cosine theta and sine theta. Now, cosine and sine, they could interchange because it's multiplication. So you have 2 of cosine x or cosine theta times sine theta. So this is the double angle formula for sine 2 theta. Okay, so double angle means there's double 2 of that angle. Now, so keeping that in mind, so we have to formulate a cosine. Now, so let's remind ourselves. So sine square theta plus cosine square theta is equal to 1. So if I can rearrange it, cosine square theta is equal to 1 minus sine square theta. Okay, now also we could say that cosine 2 theta, so this is a double angle formula. Cosine 2 theta, we're going to follow exactly like a sine double compound angle formula. And when you collect the like terms, you get cosine square theta minus sine square theta. So this is one of the double angle formula for cosine. Okay, so there are actually 3 of them you have to remember for cosine. Another one is I could replace this into over here, into equation 1. So if I were to replace it, it's going to be 1 minus sine squared theta minus sine square theta. So as you can see, you can collect the like term with sine squared. Therefore, it's going to be 1 minus, there's 2 of sine squared theta. So that's cosine double angle formula. So this is the second formula. Okay, and the another formula is cosine double angle is equal to 2 cosine squared theta minus 1. The reason is I could rearrange sine squared x and then replace sine square theta is equal to 1 minus cosine square theta. So I could now replace this with this one, and then when you collect the like terms, you have 2 cos squared theta. So this is the third equation for double angle cosine. Okay. Now, so in summary, so this is a summary. So there is only one sine double angle, okay, which looks like this. And for double angle for cosine, there's two of it. So this and this is exactly the same, but there are 3 of double angle formula for cosine. And then we have 1 double angle for tangent. Now, so we need to know how to use the formula, this one, but you don't have to memorize it. Okay, so let's see. So write as a single trigonometric ratio. So as you can see, first look at the expression and see how this expression looks similar to which of the double angle formula. So is it sine, cosine, or tangent? So we have sine and cosine, meaning it looks very similar to, it looks like sine to theta, which the formula is 2 sine theta cosine theta. So we can say let theta is equal to 3x. So therefore, I'm going to plug it into my standard formula, which is 6 2 sine theta cosine theta. Do you see it? So I factored out 6 because I want the formula to start with 2. Okay, so I replaced it with, so 6, 2 sine 3x and cos 3x. That's what it looks like. Okay, now we understand that this is exactly looking like the formula, which is sine 2 theta. So we could say 6 sine 2 theta is this double angle formula. Therefore, I could say 6 sine 2, I'm going to plug in a theta as 3x because that's what the question is in. And then you can simplify 6 sine 2 times 3 is 6x. And this is my final single trigonometric ratio. Okay. Letter B. Okay, now when you take a look at this expression, it looks very similar to cosine double angle formula, cosine 2 theta. Now, there are 3 options. If you look at your formula sheet, so 2 theta, there are 3 options, and the one that contains cos squared and sine squared is the cos square theta minus sine square theta. So I could say let theta is equal to 4x. So therefore, let's plug it in. So it's going to be cosine squared 4x and then minus sine squared 4x. So therefore, it's going to be, so if I plug it in, it's going to be cosine 2 theta, right? So that is going to be my input, okay, which is going to be cosine 2 times 4x. Therefore, it's going to be cosine 8x. Okay, so the strategies for using a double angle formula is to look at the expression and match it with the formula that we're given for double angle. And then we're going to plug in the angle into the formula. Okay, so therefore, from when I say this, I'm going to plug it in as theta. Okay, Therefore, it's going to be cosine 2 theta is equal to, so I should be writing it here. So this should be under here, equal cosine 2 4x. Okay, so this will be my final answer. Okay, let's see the next question. So write as a single trig ratio, same thing. Now 3 minus 6 sine squared. So again, what does this look like? This looks like the cosine formula, cosine double angle formula. Specifically out of the 3, it looks very similar to 1 minus 2 sine square theta. So in order to look like 1 minus 2, I'm going to factor 3. Okay, so let's factor 3. So it's going to be 1 minus 2 sine squared 5x over 2. Okay, now it looks exactly like this. So we can say let theta is equal to 5x over 2. So therefore it's going to be 3 bracket 1 minus 2 sine squared theta. It looks exactly like cosine. So I'm going to plug this as double angle. So 3 times cosine 2 theta. So therefore, it's going to be 3 cosine 2 times, so I'm going to plug in the theta again as 5x over 2 because the question is in x. And then 2 and 2 cancels out. So it's going to be 3 cosine 5x. And this will be my single trig ratio for this expression. Letter B. Okay, so we have tangent. So it looks like it's a tangent double angle formula. Tangent to theta is equal to 2 tangent theta over 1 minus tangent squared theta. It looks exactly like this, just different coefficient. So in order to look like 2 and 1 in the denominator, I'm going to factor the common factor of 16 and 8, which is 8. So let's factor 8 for the numerator. So it's going to be 2 tangent theta. Okay, and keep in mind, I'm going to let theta is equal to x. Over 8, I'm going to factor 8. So 1 minus 1 tangent squared theta. Now, what do you notice? This bracket looks exactly like my double angle formula. So therefore, it's going to be 8 tangent 2 theta over 8. Okay. But 8 and 8 we can cancel, it becomes 1. So therefore, it's going to be tangent to theta, but we know the theta is going to be x, so it's 2x. And this will be my final answer. Okay, so we have a different question now. So if tangent x is equal to 2 over 5, and it's in between pi and 2 pi, so it's going to be in quadrant 3 or 4. Okay, and it says find the exact value of x. So exact value, Okay, so now let's see. So we have to figure out it's in quadrant 3 or 4. But where is the x? So is it in quadrant 3 or 4? Let's see. Because the tangent, the ratio is positive 2 over 5, using a cast rule, it must be in quadrant 3 because only tangent can give you the ratio that is positive. So it must be in quadrant 3 because tangent is positive. So tangent theta is in this case, so we're making a triangle that looks like this. Okay, and related acute is here. So let me draw it again. So this is my related acute angle theta. So tangent is going to be opposite over adjacent. So this is x, and this is y, and this is the radius, okay, of a circle. So tangent is y opposite over x. So using this formula, we know that it's going to be, the point is going to be tangent theta is 2 over 5. So it's going to be x, y. X is going to be 5, and y is going to be 2. But keep in mind, it's in the negative direction. So we're going negative 5, and we're going down negative 2. So that's why you get this, the hypotenuse, so negative. And you will notice that it's okay to be negative because negative over negative gives you positive. So we found a point. The point is at negative 5, negative 2. So using this information, we are going to find the hypotenuse. So a hypotenuse is going to be x squared plus y squared equals, let's say, r squared. So it's going to be negative 2 squared plus negative 5 squared is radius squared. So r is equal to 4 plus 25. So it's going to be square root 29. Okay, so that is my radius. So therefore, so if I'm looking for, let's say, because we're looking for cosine 2x, the double angle. But in order to do the double angle, the formula is going to be cosine 2x is equal to, so there are 3 options. You can choose either of them, but I'm going to choose cosine squared x minus sine squared x. So to do this, I need to first figure out what is the ratio for cosine x and what is the ratio for sine x. So now that we have all the values, so this is going to be negative 2, negative 5, and this is, the radius is always positive, square root 29. I can say that sine x is going to be opposite, so this is my related, opposite over hypotenuse. So it's going to be negative 2 square root 29. Cosine is going to be adjacent. So adjacent is negative 5 over square root 29. Okay, and then tangent, we already know. It's going to be negative 2 over 5, negative 5. So negative negative becomes positive. Okay, so now let's plug in the information. So cosine squared x, so cosine is going to be negative 5 over square root 29 squared minus sine, which is negative 2 over square root 29 squared. Okay, so all I'm doing is I'm evaluating each term using the triangle, the right angle triangle, because it's asking for exact value. So let's evaluate it. So negative 5 times negative 5 is 25. Square root 29 times square root 29 is 29. Minus negative 2 squared is 4. And square root 29 squared is 29. And then I can reevaluate it. It's going to be 21 over 29. So this is my final answer if I'm evaluating double angle of cosine 2x based on the given information. Okay, so what if it's asking sine double angle formula? So from the previous note, we know that because the angle is between pi and 2 pi, so it must be here in quadrant 3, and tangent is positive, and we're making a triangle. So this is negative 2, negative 5, and y is -2, and square root 29. So sine double angle formula, there's only one formula, which is 2 sine x cos x. So let's plug in. So we understand that sine x is -2 square root 29, and cosine is -5 square root 29. So let's multiply the top and the bottom. So it's going to be 2 times 10 over 29. Therefore, it's going to be 20 over 29. 2 times 10, right? Because 2, remember, is 2 over 1. So numerator and separately done with denominator. So this would be my exact answer for sine 2x. Okay, so lastly, tangent 2x. So tangent 2x, the double angle formula is, there's only one, so sine. Now we did say tangent is going to be 2, not using sine, it's going to be 2 tangent x over -1 minus tangent 2x. Now I do want to let you know that there is another way to represent tangent to x. So rather than doing this way, because you're going to have like a fraction over fraction, another way is tangent. The formula we know, tangent is equal to sine over cosine, right? From trig ratio. So because it's double angle, all you need to do is just replace the angle with 2x. Same thing. Sine 2x, cosine 2x. So what we can do is we can use the answers from letter A and B, because we already figured out what is the exact value for sine 2x and cos 2x. So from A and B, sine 2x is going to be 20 over 29, and cosine 2x is going to be 21 over 29. So you divide, so you multiply in and out. So it's going to be 20 times 29, the outside goes in the numerator, over 21 times 29. So inside is the denominator, and 29 cancel, so you are left with 20 over 21. So that will be your exact value of x if I were to evaluate tangent to x. Okay, so that is the final expression of the ratio for the double angle formula.